Welcome to D-Lab's Ham Radio ER. Tonight, I have a national 173 receiver with a bad heart. Well, really, it has a bad transformer. Actually, it's missing. Let me show you. Here she is, a beautiful national 173 receiver. I had one of these when I was a kid. This one actually comes from a ham radio operator. Let me pop the lid. All the tubes are out of it right now, but I do have them. But look here, what's gone? The power transformer. Why is that? Because the original one went up in a ball of smoke, which they all do. Get on the web, read the reports, it happens. So what am I going to do to repair this radio? Let me show you. So here's the donor. This is a main power transformer out of a national 240D receiver. This one's good. Unfortunately, the mounting pattern does not line up with what we got in here. So there's going to be a little bit of machining involved, but when we're done, the 173 will have a great donor and hopefully take off working again. So we can get a better idea of what's required, I'm going to pull the cabinet off the 173 so we can look at the chassis and see what needs to be done to get that 240D's transformer to drop into place. Alright, so I got the back pulled so we can see what we're up against. Got a choke here. Main power transformer used to sit here. This is our donor. Okay, so he'll come in here and hopefully sit in that place, right? But take a look right off the bat, we've got a problem. Screw holes do not line up with the pattern of the old transformer. The other issue is this old bobbin here has to clear that hole. This bobbin measures approximately 3 1/4 inches from terminal to terminal. That hole is only about 2.5 inches wide. So this wouldn't be a simple task that somebody could just drill a couple holes and drop the transformer in. This one's going to require a milling machine to modify it. And the good thing is, even though I have to open this hole up for the new transformer, it could be reversible if somebody found the original and put it back in the receiver. But I doubt that's going to happen. Alright, so what I'm going to have to do is remove the chassis from the cabinet completely. I'm going to remove the choke and I'm going to remove the filter cap. I'm going to show you why I'm removing this filter cap in a minute. But I need everything out of the way because the head of the milling machine needs to be able to come down here and open that hole up to the proper dimension. Then I'll simply re-drill a couple holes for the new mounting of the 240D transformer. So here's the main filter cap, and if you look at the top, there's a big goober hanging out of it. This thing's shot. Let me take you on bottom side and show you what somebody did to remedy that. Alright, here we are bottom side, and what do we got? This guy just kind of hanging out. Filter cap. There's another one there. It's been kind of gobbed in. We're going to get all this out because the main filter cap's bad. And I have a nice replacement here. The original is a dual 10. I'm going to replace it with a 16 500 volt model. And it'll drop right in to the place of the original. Alright, so I pulled out those caps. I'm going to remove this remaining cap, get that electrolytic out, and pull out the choke. I got the chassis pulled. Pretty easy job on this receiver. Getting ready to lay out the new pattern for the power transformer. Now one thing you'll notice, if you pull the transformer all the way back to where these original studs line up with those holes, the transformer is going to hang off the back and it'll hit the back of the cabinet. So it cannot go in like that. It's going to have to be shifted forward. So what I'm going to do is I'm going to line the front bolts with these original holes. Okay. Then I'm going to open up this cavity to clear the bottom of the transformer, and then we'll re-drill these holes, leaving about a 1/4 inch gap between the transformer and the back of the cabinet. Should go right in. So here's a new layout. One mounting stud will go back in this original hole. Here, I'm going to have to slot this over a little bit. New hole here, new one here, and then here is a new cutout. So I'm going to extend it up here and across. Then we have to cut it here slightly, and that'll even it up, and the new transformer should drop in. Alright, I've got her mounted up in my milling machine. Chassis went right in there, thank God. Everything cleared. So I'll be able to move the head up and down. Plenty of clearance. So first thing we're going to do is cut the slot for the screw. Then I'll open up the cavity for the rest of the transformer. Alright, so I've got the chassis nice and secure. There's nothing under here. I'm not going to go very deep. Obviously, I don't need to. We're just going to pierce through the metal and take her that way. Lock the head. Come across. Alright, the slot's done. Now let's open up the cavity. I'm going to use plenty of cutting oil here. I'm going to kiss off this side here so I know my index. I'm just going to come up here and cut across and down. I won't torture you with the sound of the mill, but I'll cut to it after it's complete. Alright, major cut is over. Now I need to just go down here and trim that side up. Be ready for the test fit. Alright, everything's done. Got the new mounting holes. Kept that original. And we got a slot over here for alignment. There should be plenty of clearance now. This is about 3 inches this way, a little over 3 inches that way. So let's do a test fit. Alright, there she is sitting in place. I'm going to have to get it off the mill so I can drop it in. But it looks like everything's going to clear. Wires will be tight going through, but then after they clear the bobbin, there's all kinds of clearance there, so we're good. Let's give it a shot. Alright, she's in place. Quite the job. But I'd say that looks original. Should be plenty of clearance for the 6v6 to nuzzle up against it. So I think we're in good shape. I don't have the nuts on here yet, but you can see there's plenty of clearance. Primary wires are back here, so that's going to be a little bit tight, but as soon as I get it bolted in, she should come forward enough for me to get all the wiring in place. Choke is reinstalled, new filter cap's in place. It's still loose, so I can spin it where it needs to be when I align the pins underneath. Everything looks good. Plenty of clearance around the transformer. I put in that 6v6 to make sure it went in alright. Everything's cool. Time to get her wired. It's time to wire it up. So I've identified the windings. The primary is here. That's going to go up to the socket here, and the fuse holder. You have your 6-volt tap here for filaments, and I've already got that wired in. You can see the brown wire there. This green one goes to ground. 5-volt winding over there for the 5Y3. And here's our high voltage. So I'm getting ready to connect these two white wires to the negative tab of my new filter cap. You're probably wondering, why did I use that type of cap rather than one of those metal can type caps? Reason is those type caps use the outside of that aluminum can as the ground connection. This one has the individual tab. If you take a look at the schematic, right there, you'll see the filter cap sections A and B. See where the negative is? It does not go to chassis ground, it goes to another capacitor. And at this point here, they're using negative bias, which goes over and feeds the audio section. So you cannot use a standard filter type can cap unless you isolate it from chassis. The donor power transformer is wired up, as well as the choke and the new filter cap. So we're about ready to fire this thing up. But you know what's really been eating at me is what caused that original transformer to smoke. The past owner told me that when he got it, it played, but then he walked out of the room, came in after a period of time, and it was all over, and there was a lovely smell. So I thought, you know, what's the better thing to ask than the 6v6 output tube? So here it is. This is the one that was installed in the radio. Take a look at the base. This thing was running flaming hot. So I thought something's not right here. So looking over the schematic, I discovered that the center tap of this transformer does not go to ground like you would normally see on a high voltage power supply. It actually goes over to this little capacitor assembly and it develops negative voltage, guess what, to bias the 6V6. So I got looking close. This was the original cap that was sitting right there, and it was installed like that with a positive on this end. That was going to the center tap, and if you look at the schematic, which I just happen to have here, not a very good one, but there it is right there, C45, negative bias. That cap should have had positive to ground, not negative. So guess what? That cap shorted, the negative bias went away, 6V6 flamed out. It would draw excessive current until it took out the next component, which unfortunately was the power transformer. Initial power up of the NC-173. I do not have any tubes installed at this point. Got a variac over here. I'm just going to bring her up about half voltage just to make sure there's some signs of life. So there you can see about 200 volts AC coming off the transformer. Do we have lights? Yes, we do. Good. Good sign. I'm going to put some tubes in it and we'll see if the DC lines come up. All the tubes are installed. I'm still on the variac, and now we're just going to watch the DC come up, hopefully. So variac's on. If you hear any kind of funny panting, that's my dog in the background. He was just out walking. So he likes to make a lot of sounds for me. Okay, looky there. I'm at about 50 volts applied. Got 170 volts. I do have a speaker hooked up for a load. And I got a jumper wire hanging off here for an antenna. The voltage regulator's up here. 150 volts, that's an OD3. Bring my voltage up some more. I'm at 80 volts input. So 150, and down here about 230. Now that negative voltage, remember I told you that's critical. Let's see what we got. Yep, negative 35. I bet this thing will work. We'll bring it up to about 90 volts. Let's give her a little volume. Oh yeah. We have life. That's a good sign. So there's 100 volts input. About 236. That's all I needed to see. So I want to get it back in the case so it's safe to operate. Then we'll give it a full checkout, put a real antenna on it and see what it can pick up. Alright, so I'm feeling pretty good about the installation of this replacement transformer into the National 173. Luckily, the transformer from a National 240D is an exact match for this receiver. You got to be very careful when you replace these transformers. Especially pay attention to the filament current supply, because this thing pulls about 6 amps on the filament circuit. It's got 12 tubes. Divide that by half. What do you get? So you got to be cautious, because if you put in an underrated transformer, it's just going to overheat and fail again. Yes, there were some mechanical modifications required to get that transformer in this receiver, but you know what? It's the last transformer this receiver will ever need. So I hope this was good for you. I do plan on some follow-up videos, because there's no way I'm just going to plug this thing in and run it. There's many other things I want to check, and I'll be featuring that on future episodes of D-Lab Electronics. We'll see you again.